A good day to everyone who's watching. In our lesson today, we're going to talk about the inverse of a function. The inverse of a function, we have three steps there. One is to let the function to be equal to an unknown of your choice. Two, you make the x the subject, or the value that has been given there as in the function, you make it the what? The subject. For example, if it is f of y is equal to y plus 6. So if they had used y, you make y the subject. Here they have used x, so we are going to make x the subject. That is the second step. The third step is to interchange the x value you have made the subject for the inverse function. If my f of x is that, then its inverse is just denoted as that. If the function is g of x, then its inverse is b inverse of x. If the function is h inverse, then its inverse is the original function. So our first step, we have said we let, I'm going to use y to be equal to the function x plus 6. Like that. Then I make x the subject of the formula. That is taking the 6 this side. This is going to be y minus 6 is equal to x. So I've made x the subject of the formula. This one rewriting is the same as x is equal to y minus 6. Just rewriting these two. Then the third step is to substitute for the x as the inverse. Then you substitute this unknown as the x. So the inverse function of f of x is now going to be x minus 6. As simple as that. Now, these inverse functions, when we go back to the domain and the range, suppose I'm having, let me give myself here some values there, 1, 2, 3. When I feed them there, the function, in the function there, that is x plus 6. So when I feed that, I get 7. When I feed this, I get 8. Then when I feed that, I get the 9. So the inverse function is that function that takes back the images back to the original objects. So when you try to see this, the f inverse, as this one was the f of x, this one here is going to be the f inverse of x as x minus 6. So when you try to put 9 here, it will be 9 minus 6, taking you back to 3. When you put 8 here, 8 minus 6, it will take you back to 2. When you put 7 here, 7 minus 6, it will take you back to a 1. So we had that function that was taking us from the domain to the range. Now we are getting values that are taking us from the range back to the domain there. Yeah, so that is how interesting the functions are. Example 2, given our g of x is equal to 3 all over 4 x minus 6. Find the g inverse of x. We have said step 1, you let m to be equal to the function. Step number 2, you make x the subject of the formula. When I look at this, I need to first take the minus 6 away by adding it both sides. Then I also need to take away the multiplication of 3 all over 4. So to kill that is to multiply both sides by 4 over 3. So this is going to be my m plus 6 into my 4 all over 3 is equal to 4 all over 3 then times the 3 all over 4x. So this one here, I'll be having a 1, then 1 times x is going to be my x. So x is equal to 4 all over 3 as the x. Then I conclude that my G inverse of x is equal to the 4 all over 3 into the x plus the 6. As simple as that. Then part B, I've been told to find the G inverse of 1. Then I come and I substitute here in the G inverse of x. Remember, even the inverse is a function itself. If I've been asked the G inverse of 1, I must make sure that I have the G inverse of x. So I come here and I substitute where there's x, I substitute a 1. So this one is going to be equal to 4 all over 3 into 1 plus 6. So I add inside, I'll be having 4 times 7 all over 3. Then finally, I have my 28 all over 3 as the G inverse of 1. Example 4, if h of x is equal to 2 root of x plus 3, find the h inverse of x. Step 1, you let my k be equal to the function 2 times the square root of x plus 3. Then I look for ways of making x the subject. X is under the root, but before the root, there is a 2 which is multiplying the root. So I can first divide both sides by that 2. So this is k all over 2 is equal to the square root of x plus 3. Then now I look for ways of eliminating the square root. How do I eliminate the square root? By squaring both sides. So I come this side, I square. I also come this side, I square. So this is going to be equal to k all over 2 squared is equal to this one here is x plus the 3 because the square cancelled with the square root. Then now I look for what is stopping me from making x the subject is the positive 3. I'm going to subtract 3 both sides, then I eliminate the positive 3 this side. So this is going to be k all over 2 squared minus 3 is equal to my x. Then therefore I conclude that my h inverse of x is equal to x all over 2 squared, then minus a 3. Our example for there, if the f of x is equal to 2x plus 5, find the value of f inverse of 11. Now here we have two alternatives. You can either first find the f inverse of x, then you get the f inverse of 11, or we can just substitute that this is the 2x plus 5 is equivalent to 11. Then from here, I get my value of x. So when I take 5 the other side, it is positive. Now it becomes a negative. This is the 2x. Then when I subtract, I'll be having a 6. Then divide both sides by 2, and that way by 2 to get the value of x as a 3. Then you come down here and you conclude, therefore, the f inverse of 11 is now what? Is now a 3. We have said you can first get the f inverse of x following the steps that we talked about, the 3, letting m be equal to 2x plus 5. This is going to be 5 minus m minus 5 is equal to 2x. Then you divide both sides by 2, and that way by 2 to get the value of x as m minus 5 divided by 2. Then there you get the f inverse of x as x minus 5 divided by 2. Then from there you get the f inverse of 11. When you substitute here, this is 11 minus 5 divided by 2, and then you will end up getting a 3, because this is 6 in the numerator divided by 2, which is a 3. So when they ask directly without first asking for this, you can just use this very quickly and get the answer. Our next example there, find f of x if the f inverse is equal to x squared plus 1. So we say to get the original function is that you need to get the inverse again here, because when we have the domain and the range, we said that one which takes us there is the f of x, and that one which takes us back there is the f inverse of x. So if I need now the original function, that means that I need to get the inverse again. So step 1, we said you let y be equal to the function x squared plus 1. You make x the subject. The 1, I take the other side, it's going to be y minus 1 is equal to x squared. Then how do I kill the square? Is by taking the square root both sides. So square root is equal to y minus 1 under square root. The x value here is going to be equal to plus or minus square root of y minus 1. Then I conclude that my f of x is now the plus or minus square root of x minus 1. So we can talk about a function being undefined. Being undefined is the same statement as meaningless. When we go to the examples, example 1, find the function. Example 1, if the function f of x is equal to x squared plus 9 all over 3x minus 5, find the value of x for which f of x is meaningless. Now, when they say meaningless, just get the denominator and equate it to 0. So whenever we hear of meaningless, our denominator is equal to 0. So the denominator is the 3x minus 5. This one is equal to 0. Then I take the negative 5, the other side, that is 3x is going to be equal to 5. Then I divide both sides by 3. Then I get the value of x as 5 all over 3. So our example 2 there, find the value or values of x for which the following functions are undefined. Part A, our f of x is that one there. So we need to get the denominator and we equate it to 0 and then get the corresponding value of x. So from our f of x, the denominator there, we say if it is meaningless, denominator should be equal to 0. So that is 8 into x plus 2 should be equal to 0. Dividing both sides by 8, I'm just now simplifying. So I'll be having x plus 2 is equal to, when I divide this side, I have a 0. I take the 2 the other side, so I get x as negative 2. Then when I go to part B, the denominator there is x squared minus 9. and this one here, we have said we equate it to 0. I take the 9 the other side, so this is x is going to be equal to positive 9 because this side has been negative. Then I take the square root, both sides, so I'll be having x as plus or minus 3. Part C there, we have been having x squared plus 7x plus 12. That has been the denominator for the h of x there. So I'm equating it to 0. Now this equation here becomes a quadratic equation. So the quadratic equation, we need to get the sum and the product. So the sum is positive 7. Then the product is also positive 12. Then we look for two factors that can give us these two conditions here. So when we look at the factors of 12, there's a 3 and a 4. When you multiply 3 and a 4, you get positive 12. When you add 3 plus 4, you get positive 7. So those factors there, they are positive 3, positive 4. So I'm going to substitute them there where there is the sum. So this becomes x squared plus 3x, then plus 4x, then plus 12 is equal to 0. Then I'm going to factorize these two. X into x plus 3, then plus, factorize these two. What is common there is the 4, then into x plus 3 is equal to 0. Again, I'm going to factorize these two terms because the x plus 3 is common. So when I pull it out, here I'll be left with x, then there I'll be left with the positive 4 into x plus 3 to give me a 0. Then either one bracket is 0, either x plus 4 is equal to 0, or x plus 3 is equal to 0. So here I get my x value as negative 4. Here I get my x value as negative 3. Find the inverse functions of the following functions. Part A, our h of x is equal to x all over x minus 3. So we said step 1 is to let the unknown of your own wish to be equal to that function, x all over x minus 3. Then step 2 is to make x the what? Then step 2 is to make x the subject of the formula. This one here, this side, we have a numerator and a denominator. Then I need to cross multiply. So when I cross multiply there, I'll be having m into the x minus 3 is equal to x. Opening brackets this side, this is going to be mx minus 3m is equal to x. Then now I'm going to collect like terms of x. That is, I'm going to take this x this side, then the negative 3m the other side. So this is going to be mx minus x is equal to positive 3m. Because it has crossed equal sign, it's now positive. This one has come this side, it's now negative. Then factorizing what is common there in those two terms on this side of the equation is the x, then into m minus 1 to be equal to 3m. Then to make x the subject is to divide by this bracket which is now multiplying. Then finally I get the x as 3m divided by m minus 1. Therefore, the last step is to interchange the h inverse of x. It's going to be equal to 3x all over x minus 1.